Hello guys, and welcome back to another video. So in this video we'll be looking at electrostatics. Now let's get into it. So here our statement reads that two identical insulated spheres X and Y suspended by threads from a ceiling are held at a small distance apart as shown in the diagram below. And these are our two spheres, and as we can see they are oppositely charged. This one is positively charged, meaning it has excess protons. This one is negatively charged, meaning that it has excess electrons. Another thing that we know about oppositely charged spheres is that they are going to attract, okay, due to them being unlike charges. So they are going to attract. Yes, there's going to be an attraction between these two. Now let's look at another statement. It says sphere X carries a charge of positive 4 times 10 to the power of negative 18 coulombs, while sphere Y has an excess of what? 30 electrons. And then they say calculate the magnitude of the charge on sphere Y. Okay, so let's find our charge on sphere Y. For us guys to find that charge, we have to look at the information that we have. Okay, first of all, let's start with the one that we don't have. In terms of this one, we are looking for what? We are looking for Q. But what are we given? We are given this. Okay, we are given the number of electrons, and that's N. Okay, so that's the information we have. We have the number of electrons and we are looking for Q. Now the question that we have to ask ourselves is which formula then are we supposed to use in this case? Well, the formula we'll use is N is equal to Q divided by E. Okay, that's the formula we'll use, and we find this obviously on our formula sheet. I'll quickly show it to you. So the formula guys we use is this one, as you can see for that question. N is the number of electrons and Q is the number, or is the charge. E guys is the charge of an electron, which is a constant. Where are we finding that one? The charge on an electron, which is E, is here. It's over here. That's where we are going to find it, as you can see. All right. So now guys, what we are going to do next is to substitute into our equation. All right, let me just erase this part. We are now substituting. Okay, where we see N, what are we going to put? Remember we said N is equal to what? The number of electrons, which is 30 in this case. So it means we have 30 electrons is equal to the Q we do not have divided by the E. Remember the E is the constant, which is negative 1,6 times 10 to the power of negative 19. And then from there we'll just use our calculators and cross multiply. If I cross multiply, say Q times 1 and I get Q, then I say 30 times negative 1,6 times 10 to the power of negative 19. What's going to be my answer? My answer guys will then be what? Negative 4,8 times 10 to the power of negative 18. What's the unit for charge? It's going to be coulombs. And that's how I work out this problem guys. How do you get your marks here? Get a mark for the formula, get a mark for substituting into the formula, and you get a mark for the final answer. Okay, that's how we do that one. Now let's move on. They say the spheres are now released and then they move towards each other. Obviously they are going to move towards each other guys because they are oppositely charged. But now they ask the question of give a reason why spheres X and Y move towards each other. It's because of what we've already said. They have unlike charges. Okay, so that's what we'll write. That is because they have unlike charges so this is how we'll answer the question guys, that by saying that it's because they have unlike charges and unlike charges attract. Yes, that's your reason. Okay, now we go to the next part. They say the spheres are allowed to touch each other. After touching, they move away from each other. And then 10.3 says state the principle of conservation of charge in weights. Okay, I will write it for you guys. So this is going to be our answer, guys. You will say that the total or net charge in an isolated system is conserved or remains constant. That is the principle of conservation of charge in weights. Okay, that's the answer for 10.3. Now we move on to 10.4. Okay, 10.4, guys, says calculate the charge on each sphere after they have separated. And guys, the formula you use for that question, especially every time you see what separation or after they've come into contact and moved away from each other, the formula you will always use is Q is equal to Q1 plus Q2 divided by 2. And electrostatics, guys, only has two formulas, okay, in grade 10. So you don't have to stress here. You just need to understand where do you use which formula, in what situation do you use a certain formula. This one works after the two charges have come into contact and then separated. Okay, now we are going to substitute into the formula. We look at Q1. Q1 has to be this charge here, or the charge of what? Of sphere X. Okay, so that's Q1, and if we write it down, it's going to be what? It's going to be 4 times 10 to the power of negative 18 plus the plus of the formula. What is Q2? Remember that we found Q2 as negative 4,8 times 10 to the power of negative 18. If you forgot about that, this is where we found it. This was the charge for y, okay, sphere y. We found it as negative 4,8 times 10 to the power of negative 18, right? And then we divide all of this by what? By 2. Then go to the calculator for the final answer. So guys, when you press our calculator and say 4 times 10 to the power of negative 18 plus negative 4,8 times 10 to the power of negative 19 divided by 2, the answer we get is negative 4 times 10 to the power of negative 19 coulombs, and that's your answer. All right, that's how you answer this one. And in terms of the marks, you will get a mark for your formula and then substitution of each charge, and finally the final answer. I hope, guys, this question made sense. If you didn't understand anything, simply just rewind the video, play it again, and hopefully that is gonna work in your favor. Please don't forget to like. Please also share with your friends, and of course, if you've not subscribed, please subscribe. We'll see you on the next video. Goodbye.